Dev Juniors. Ever wonder how a squad in Fortnite or an enemy in Grand Theft Auto 5 instantly finds the shortest, most natural route around a complex map? They're not just guessing. They use a powerful technique called navigation meshes, or NavMesh for short. It's the spatial partitioning magic that makes game characters move with intelligence. And today, we're going to break down exactly how it works. Before NavMesh, old-school games often used grids. Imagine the entire game world sliced up into a giant checkerboard. To find a path, an AI character would simply hop from one square to another. This works for simple 2D games, but in a massive 3D world, it's incredibly inefficient. Think about it. A huge open area would need to be broken down into thousands, maybe millions of tiny squares. And if a character wants to move diagonally, they're forced to take a jagged staircase-like path. Movement looks blocky, unnatural, and computationally expensive. For the large open worlds we love today, we needed a much smarter search space. This is where the NavMesh solution comes in. Instead of breaking the world into countless tiny squares, NavMesh decomposes the walkable area into large, convex polygons, usually triangles or quads. An NPC no longer needs to think about navigating thousands of individual grid cells. Instead, it only needs to navigate a few hundred large polygonal areas. This is the power of polygonal geometry. The NavMesh is an abstraction, a simplified map that only contains the information an AI needs, where it can and cannot go. It's a clean, elegant layer that covers all the floors, ramps, and pathways, while completely ignoring walls, obstacles, and steep drops. This fundamental shift from a grid to a polygon-based system is what makes modern AI pathfinding so fast and believable. So how is this magical map created? This happens through a process called baking the mesh, and it's typically done in the game engine before the game even runs. This pre-calculation step is crucial for performance. The engine essentially scans the entire 3D environment and does a sort of geometric analysis. It identifies all the surfaces that an AI character could realistically walk on. Is the surface flat enough? Is it wide enough for the character to pass through? Is it connected to other walkable areas? Based on these rules, it generates the mesh, covering all the navigable areas with interconnected polygons. The result is a lightweight, pre-computed data structure that perfectly represents all possible pathways in the level. This is a classic example of spatial partitioning, where we divide up the game world to make searching through it much faster. Now we have our baked mesh. What happens when an NPC actually needs to find a route from point A to point B? This is the pathfinding step. The character runs a search algorithm, very often the famous A** algorithm. But here's the key difference. It runs the search on the NavMesh itself, not on the detailed, complex game world. The path is no longer a sequence of grid squares, but a sequence of polygon transitions. Imagine a path from one side of a room to another. The search might only need to identify a sequence of 5 or 10 large polygons to get there. Because the search space is dramatically smaller, we were talking hundreds of polygons. Instead of millions of grid cells, the calculation is practically instantaneous. The game can find a complex path across a massive map in a fraction of a second. The output of this step is a simple list of polygons that form a corridor from the start point to the end point. But that's not the final step. The Pathfinder gives the rough route the corridor of polygons, but the NPC still needs to steer smoothly along that path. Just following the center of each polygon would still look a bit robotic. This is where steering behaviors come in. A common technique used here is the funnel algorithm. It takes the corridor of polygons and finds the absolute straightest, most efficient line through it. It's like pulling a string tight through a series of hoops. This algorithm allows the character to cut corners within the navigable corridor, creating a path that looks natural and intelligent. It also allows the NPC to understand the boundaries of the NavMesh, so it can move smoothly alongside a wall without ever bumping into it. The combination of an asterisk on the mesh and a smart steering algorithm like funnel is what produces that fluid, goal-oriented movement we see in games. So, NavMesh is the invisible backbone of modern game AI. It's the reason characters in games like Apex Legends, Fortnite, and GTA V can navigate huge, dynamic worlds with such believable intelligence and efficiency. It's a perfect blend of pre-calculation, smart data structures, and efficient algorithms. The next time you see a character flawlessly chase you through a building or navigate a chaotic battlefield, you'll know the polygonal secret behind their every move. What's your favorite example of game AI in action? Let me know down in the comments. Thanks for watching, and if you enjoyed this deep dive, don't forget to like and subscribe to Dev Jr. for more. See you next time.